we have a rover on Mars the size of an SUV that brought a helicopter with it.
Yes.
Okay? So what are you complaining about?
Let's start with something obvious for the people out there who don't necessarily believe in the final frontier. Let's start with you as the commander, Reed. Why are we going back to the moon?
Because we want to see humans on Mars.
The most astonishing footage of Mars ever sent to Earth has revealed a groundbreaking truth. NASA's Perseverance and Curiosity rovers captured Mars like never before, in stunning 4K, uncovering a hidden water-shaped past. Ancient lake beds, sediment layers, and even tantalizing methane signals paint a vivid picture of a planet that was once alive with possibility. A discovery that shakes our understanding of the red planet to its core. Let us now journey deeper into Mars's mysterious terrain, where the latest findings are rewriting history. A rover's quest for ancient secrets. The mission began with one daring goal: to determine if Mars ever had the right conditions for life. At the same time, it aimed to assess whether the planet could one day support human explorers. Every aspect of this mission was a gamble, from the nail-biting descent to surviving on a barren, alien landscape millions of miles from Earth. But the latest transmission revealed something so shocking, it could rewrite everything we know about life in the universe. The landing itself was a high-stakes challenge. NASA's Jet Propulsion Laboratory invented entirely new technologies, including the Sky Crane system, to safely deliver Curiosity to Mars's surface. This untested method carried immense risk. Failure would have meant the end of the mission before it even began. But against all odds, the rover landed smoothly in Gale Crater. That marked the beginning of an extraordinary journey. Gale Crater was chosen as the landing site for its scientific promise. At the heart of the crater stands Mount Sharp, a towering formation made up of layered rock that chronicles Mars' geological history. The lower layers are rich in clay minerals, hinting at ancient water, while the upper layers hold sulfur and oxygen-bearing minerals, suggesting a dynamic and changing environment. Exploring these layers is like flipping through a time machine, revealing the secrets of a planet's distant past. Curiosity wasted no time getting to work. Its first task was to capture images of itself and its surroundings, creating a composite selfie from a series of navigation camera photos. This gave engineers a clear view of the rover's condition after landing. Concerns that dust from the landing might cover its instruments proved unfounded. The rover's deck was clean and ready for science. The rover's suite of advanced tools turned it into the ultimate Martian investigator. Among its instruments, the ChemCam stood out as a game changer. Using a laser, it could vaporize small areas of rock and analyze the light emitted to identify the minerals present. One of its first targets, a rock nicknamed Coronation, was zapped with a laser pulse as hot as the surface of the sun. From a tiny vaporized spot less than a millimeter wide, Curiosity gleaned a detailed chemical analysis. Beyond laser zapping rocks, Curiosity drilled into the Martian surface, scooped up soil, and even baked samples in its onboard lab to analyze the gases released. One of the most intriguing discoveries involved methane. Although the amounts detected were minute, methane's presence raised questions about whether it could be linked to biological activity or geological processes. Methane on Earth is often associated with life, making these findings an exciting piece of the Mars puzzle. As it climbed Mount Sharp, Curiosity uncovered ancient lake beds, further evidence that water once flowed on Mars. The minerals it found suggested that the planet was once much warmer and wetter. These findings transformed our understanding of the red planet, painting a picture of a world that might have been hospitable to microbes billions of years ago. The journey hasn't been without challenges. The rover's wheels, for instance, have suffered damage from the rough Martian terrain. Engineers devised clever strategies to extend their lifespan, such as selecting smoother routes and adjusting driving techniques. Despite these hurdles, Curiosity has continued to exceed expectations, exploring well beyond its initial mission timeline. Every part of Curiosity, from its nuclear power source to its cameras, underwent rigorous testing before launch. Engineers simulated Mars-like conditions by flying radar equipment over Earth's Mars analog landscapes and testing parachutes under extreme circumstances. These efforts ensured the rover could endure the harsh Martian environment and succeed in its ambitious objectives. Curiosity's achievements have laid the groundwork for future missions, including the Perseverance rover, which is currently hunting for signs of ancient life and collecting samples for eventual return to Earth. Despite the arrival of newer technology, Curiosity's legacy remains unmatched. It has shown that venturing into the unknown can lead to profound discoveries and inspire further exploration. 15 years on Mars. That's how long the Curiosity rover has been cruising the red planet, taking photos, drilling rocks, and studying the air. It's not just a machine, it's an explorer and a scientist. Every move it makes tells us a bit more about Mars's past, unlocking mysteries one by one. On its 20th Martian day, known as a Sol, Curiosity put its ChemCam to work. This tool zaps rocks with a laser to see what they're made of. It's a portable lab built for extreme conditions. Around the same time, the rover's wheels left behind an unexpected signature. The letters JPL, written in Morse code, were stamped into the surface. It wasn't just a mark of pride, it was a clever way to measure how much the wheels were slipping on the sandy terrain. By its 26th Sol, Curiosity had already driven more than 100 meters, a distance longer than a football field. This was a significant milestone, proving the rover's ability to navigate the rocky Martian surface. The rover's team on Earth monitored each move carefully. The navigation system is a mix of high-tech cameras, sensors, and software that let the rover assess its surroundings and plan each safe step. It doesn't just barrel forward, every movement is deliberate and calculated to avoid danger. Ahead of the rover lay a destination called Glenelg. This was no ordinary spot. It was where 3 different types of terrain came together. The name Glenelg is a palindrome, meaning it reads the same forward and backward, chosen because Curiosity would pass through it twice, on the way in and out. The site promised a treasure trove of geological data, making it a priority for exploration. Curiosity lands on Mars, ready to explore a world shaped by water and time. Curiosity's ongoing odyssey. Even before Curiosity landed, scientists back on Earth had created detailed maps of the area using images from orbiting spacecraft. They divided the landscape into grids, naming each section after small towns from Earth. Whenever they found something interesting, they borrowed names from geological features near those towns. This system helped keep track of discoveries in the vast and varied Martian terrain. Curiosity's robotic arm is an essential part of its design. It's equipped with a suite of tools that make it a mobile laboratory. There's Molly, a camera that captures detailed close-up images of rocks and soil. Then there's APXS, a device that analyzes the chemical elements in rock samples. It also carries a drill for breaking into solid surfaces, along with a scoop and sifter to prepare samples for the rover's onboard labs. Watching Curiosity in action is like seeing a robotic ballet, with each move executed with precision, despite being controlled from millions of miles away. One of the first rocks Curiosity studied was named Jake Matijevich, after a NASA engineer who contributed significantly to Mars rover designs. By combining data from its tools, the team determined that the rock was volcanic in origin and had likely formed in an environment with water. Discovering evidence of water is a central goal of Curiosity's mission, as it provides clues about whether Mars could have supported life in the past. Over time, Curiosity's findings painted a clearer picture of Gale Crater, the area where it landed. The crater once had rivers that flowed into a long-standing lake. Layers of rock and sediment preserved the history of these ancient waterways. The rover's onboard laboratory, SAM, studied Mars's thin atmosphere and found evidence that it was much thicker billions of years ago. A denser atmosphere would have been able to hold liquid water on the surface, but over time, solar winds stripped much of it away, leaving the cold, dry planet we see today. Yellowknife Bay turned out to be an area of great interest. The rocks here had features that hinted at a watery past, including tiny spherical formations called concretions. These are often formed when water moves through sediment, leaving behind mineral deposits. Some scientists speculate that similar features on Earth are created by microbial life, raising the tantalizing possibility that Mars might have once hosted living organisms. In 2013, Mars moved behind the Sun from Earth's perspective, cutting off communication between the two planets for about a month. NASA prepared for this by programming Curiosity with a list of tasks to complete on its own. Even without direct input from Earth, the rover continued its work, drilling into rocks and capturing detailed images of its surroundings. As the years passed, Curiosity continued to climb higher up Mount Sharp, the central peak within Gale Crater. Each meter it ascended provided new insights into Mars's geological history. The mountain's layers act like a time capsule, preserving evidence of how the environment changed over billions of years. Lower layers show signs of water activity, while higher layers reveal how the planet became drier and colder over time. Curiosity's discoveries have transformed our understanding of Mars. It confirmed that the planet once had the conditions necessary to support life, even though no direct evidence of life has been found yet. The rover has also provided valuable data about Mars's atmosphere, weather patterns, and the processes that shaped its surface. Each new finding brings us closer to understanding whether life ever existed on Mars and what the planet's future might hold. Even after 15 years, Curiosity shows no signs of stopping. Its instruments remain in good condition, and its mission continues to inspire scientists and engineers. As it moves further up Mount Sharp, the rover is not just exploring a distant world, it's laying the groundwork for future missions that might one day bring humans to Mars. The red planet still holds many secrets, but thanks to Curiosity, we are closer than ever to unlocking them. 15 years later, Curiosity's journey across the Martian surface is a mix of thrilling discoveries and grit. Mars has a way of keeping secrets, but our little rover has been chipping away at them one rock and sand dune at a time. Let's take a ride back through some of its adventures, the lessons learned, and the mysteries that still hang in the thin Martian air. Then there's this mini cliff, barely half a meter tall, pockmarked with holes filled with tiny islands of other materials. What's the story here? Is it volcanic rock that bubbled up ages ago? Or maybe mud that gas fizzed through, leaving behind these odd formations? The more we look, the less we know. Mars seems to revel in presenting puzzles rather than solutions. And the sky? Curiosity's eyes are always scanning. It's caught Mars's inner moon, Phobos, sliding past its smaller sibling, Deimos. These moons aren't like Earth's hefty satellite. They're tiny, zipping around close to the planet. During solar transits, they're not even big enough to block out the sun completely. Still, it's a reminder of how otherworldly this place really is. Rocks and dunes hint at Mars's watery past as Curiosity faces new challenges. Triumph and turmoil on the red planet. Moving along to a spot named Darwin, we find cracked rocks filled with minerals left behind when water evaporated ages ago. The hardened minerals are all that's left, standing as stubborn markers of time. Curiosity's cameras get up close, snapping ultra-detailed shots of these rocks, not the sharpest on Mars, but definitely the most mobile. As Curiosity rolls closer to Mount Sharp, the rover's 6 metal wheels start taking hits. Mars isn't kind to hardware. Sharp rocks have left dents and holes, making it clear that every mile comes at a cost. The solution? Drive less, drill more. Slow and steady wins the science race. Speaking of clever moves, Curiosity approaches Dingo Gap, a sand dune just 1 meter high. Sounds easy, but loose sand could trap the rover for good. To be safe, it takes the unusual step of reversing through the dune. Turns out the sand isn't mud despite its color, just a trick of the Martian light. At a site called Kimberley, the team starts piecing together the Martian story. Layered terrain hints at rivers and deltas that once carved up the land. It's a snapshot of a wetter Mars, where water was more than just a fleeting visitor. Every rock tells a story, from sandstone fragments to manganese deposits that suggest oxygen once flowed through this alien world. One day, Curiosity's camera spots something unusual, a chunk of iron meteorite lying among the pebbles. Dubbed Lebanon, this relic probably came from deep inside a shattered asteroid. On Mars, where life might never have taken root, finding pieces of other worlds feels oddly poetic. And then there's the fireworks. After more than 1 Martian year, that's 687 Earth days, Curiosity celebrates by shooting its laser at a rock named Nova, creating a plasma ball that's both science and spectacle. As the rover ventures into Hidden Valley, it encounters bright, flat stones that stand out against the sand. One target, Bonanza King, proves too unstable to drill, forcing the team to move on. Mars isn't making it easy, but that's part of the thrill. Back on Earth, scientists face a new challenge: microbes, biomos. Turns out some tiny organisms can survive the sterilization process used on spacecraft. This raises a big question. Could we accidentally contaminate Mars with Earth life? Curiosity can't detect microbes directly, but the possibility of hitchhiking organisms adds another layer of complexity to its mission. 15 years might sound like a long time, but when you're unraveling the mysteries of an entire planet, it's just the beginning. The journey across the red planet isn't just about gathering data, it's about rewriting what we know of our own solar system. Curiosity's mission has always been to decode the history of Mars, and every dusty trail it leaves behind adds a new chapter to that story. Take, for instance, the vast plains it's crossed, filled with rocks scarred by ancient winds. These formations hint at a time when Mars had a more substantial atmosphere, capable of shaping its surface. The ChemCam's laser zaps reveal mineral compositions that speak of a dynamic past, where fire and water clashed to create the surface we see today. These aren't just barren rocks, they're pages of a book that's been weathered by time. The journey has had its setbacks. The rover's wheels, though designed for tough terrain, have taken more damage than expected. Dents and tears in the metal serve as a stark reminder of the planet's unforgiving nature. Yet every setback is met with ingenuity. By adjusting driving strategies and carefully choosing paths, the team ensures that Curiosity can keep going, mile after mile. Curiosity's journey to Mount Sharp is perhaps its most ambitious goal. This towering feature, rising over 3 miles, holds clues to Mars's climatic evolution. The lower slopes tell stories of ancient lakes and flowing rivers, while the upper layers might reveal a transition to the dry, cold Mars we know today. It's like walking through time, each layer offering a glimpse of a different era. At every stop, Curiosity's instruments are put to work. The Mars Hand Lens Imager captures close-ups of rock textures, while the Alpha Particle X-ray Spectrometer analyzes chemical elements. Each tool adds another piece to the puzzle, building a picture of a world that's more complex than we ever imagined. One particularly intriguing discovery came at a site dubbed Yellowknife Bay. Here, Curiosity drilled into mudstone, uncovering evidence of an ancient environment that could have supported microbial life. The presence of key ingredients, carbon, hydrogen, oxygen, and nitrogen, paints a picture of a once habitable world. It's not proof of life, but it's a tantalizing hint. The journey isn't just about rocks and minerals, it's also about understanding the environment. By measuring radiation levels, Curiosity helps scientists assess the risks future astronauts might face. The rover's weather station records temperature, wind, and humidity, providing a snapshot of daily life on Mars. These data points are critical for planning human exploration. Curiosity's cameras have also captured some breathtaking views. Panoramic shots of the Martian landscape show a world that's both alien and strangely familiar. The rust-colored hills, the distant mountains, and the endless sky create a sense of vastness that's hard to put into words. These images are a reminder of why we explore, to see what's out there, to push beyond the boundaries of our own world. 15 years on, Curiosity's mission continues to inspire. It's a story of perseverance, of pushing the limits of what's possible. As it climbs higher on Mount Sharp, the rover keeps uncovering new secrets, proving that there's always more to learn. Mars may be a harsh and distant world, but through the eyes of Curiosity, it's a place of wonder and endless discovery. Next, there's Whale Rock, not named for its size, but for its story. This formation reveals how water ripples slowed as they flowed into an ancient lake, depositing mud and stones in layers. Think of a river spreading into a lake back on Earth, leaving behind a fan of sediments. That's what happened here, again and again over tens of millions of years. These silt layers, stacked like pages in a book, showcase a repeating cycle of lakes filling and drying, rivers carving paths, and Mars's climate swinging between wet and dry spells. Did Mars's ancient lakes and rivers cradle life, or are we chasing shadows in the dust? Share your thoughts in the comments like this post, and subscribe for more explorations.